Okay, so we got a couple things I want to cover here before we call it a day. First is, we talked about estimating with the addition and subtraction in our decimals. I held off on doing that with the multiplication and division because it can be a little bit more difficult. When we had our whole numbers we were estimating, when we estimated something like 4,000 times 200, if you recall, we took the numbers, the 4 and the 2, and we multiplied them to get 8. Then we took the zeros. When we're multiplying, we just added them together. We got 1, 2, 3, 4, 5 zeros. So 800,000. If we had Oh, 60,000 times 50. Well, 6 and 5 make 30, but we still have 5 zeros to add on to it. 3 million, yes. The 5, even though there's already a 0 here, that doesn't count. We got to add the 5 zeros to it. So we get 3 million. When we're dealing with decimals, it's a very similar process. Only it's not zeros that we're counting anymore, it's decimal places. Good. So just like over here, 4 times 2 is 8. Here, 4 times 2 is 8. Over here, we counted 1, 2, 3, 4, 5 zeros. Here we count 1, 2, 3, 4, 5 decimal places. We have to have 5 decimal places in our answer. Make sense? So if I had 6 10,000ths times 500ths, I'm going to get 30. Then I have to have 1, 2, 3, 4, 5, 6 decimal places. Now this 0 does count 1, 2, 3, 4, 5, 6 decimal places. Make sense? You look confused over there. A little bit? Okay. Well, if you think about it, remember you're always taught you had to count 1, 2, 3, 4, 5, 6 decimal places to figure out where to put your decimal. Yep, so you just have to do the same. 1, 2, 3, 4, 5, 6. And it's the same. I'm just trying to make that connection between that process and the zeros when you're estimating with the larger numbers. You can see there are all these connections in math that we fail to make on a regular basis. When you start seeing all the connections, there's a lot less rules to memorize because all the rules come from the same basic concepts. So if you know the basic concepts, the rules start to become obvious to you. When we divided, we had 800,000 divided by 400. We divided the numbers. 8 divided by 4 was 2. Then what do we do with the zeros? Cancel. We have 2 zeros here, so I'm going to cancel out 2 zeros here, leaving me with 3. Or I subtracted zeros, however you wanted to do it. You have 5 zeros minus 2 zeros, leaves me with 3 zeros. If I have 60,000 divided by 2,000. That's 6 divided by 2, which is 3. How many zeros? I got 3 zeros. I'm going to cancel out 3 zeros, leaving me with 1. So I get 30. When I'm dividing with decimals, same thing. When I had large numbers, I canceled out the zeros. When I have decimals, I cancel out decimal places. Here I have 8 divided by 2 is 4. I have 3 decimal places here. So I'm going to cancel out 3 decimal places here, leaving me with 2 decimal places. So I have 1, 2, 0.04. think of it this way. I'm going 1, 2, 3 decimal places, 1, 2, 3 decimal places, then divide. Yeah. But again, just like here, 5 zeros minus 2 zeros leaves me with 3 zeros. 5 decimal places minus 3 decimal places leaves me with 2 decimal places. Same type of concept. Just looks different because it's with decimals. Yeah?
Oh, yeah.
Well, I mean, you can always just do what I did here. The number you're dividing by, you got to turn it into a whole number, so you got to move the decimal place 1, 2, 3 spots. You move this decimal place 1, 2, 3 spots. So that's where your decimal point has to be. Divide that by 2. And give you 0.04. That always works. So the same here. 6 divided by 3 is 2. I have 2 decimal places, so I'm going to remove 2 decimal places. Leaves me with 2. Or again, 1, 2, 1, 2. So it's 0.06 divided by 3, which would be 0.02. Just again, you don't have to use that. It's just a way of estimating. If you are trying to estimate with decimals, it's a way of dealing with them. Now, I've already talked a little bit about taking something like 0.096 and turning it into a fraction. What's that going to become as a fraction? 96 over 1,000. Okay? And of course, that can be reduced by that by 2. Okay, let's do 2. 48 over 500. Can 1,000 be divided by 3?
No.
Not quite.
By
We divide by 2 again. 24 over 250. 2 again. You got 12 into 125, and that's as far as you can go right there. Yeah.
3 doesn't go into 1,000, like I said.
It's okay. It works.
Hey, you can if you want to.
3 goes in there. There's just some left over. Here's the thing. I always explain to people, because I have students in one of my other classes, he answers a lot of questions and he gets one wrong. Every now and then he gets frustrated. And I tell him, there's a lot of people in the class that haven't said any wrong answers, and that's mainly because they haven't said any answers. So
That's why it was so quiet.
yeah.
Hello?
I'd rather have you give a few wrong ones here and there than not give any at all. Exactly. Tell you what, the mistakes I have made in my life, those are the ones I've learned the most from, because I'm stubborn. I don't ever want to make that same mistake again. So, I mean, things that I screwed up or had a problem with, those are the things I've learned the best, because I'm never going to make that mistake again. Okay, so what about going the other direction? What if we have a fraction and we want to turn it into a decimal, like 3/8? Well, remember we said a fraction can be thought of as a division problem. So this can be 3 divided by 8. Now, of course, 8 doesn't go into 3. So what do we have to do? Add a decimal point. Before we can add zeros, we have to put that decimal point in. No, 3 divided by 8. Since 8 doesn't go into 3, you put a 0 there. What's that? So we move the decimal point straight up. Now 8 does go into 30 3 times. That's 24 with 6 left over. Adding another 0 and bringing it down. 8 goes into 60. 7 times. That's 56 with 4. Add another 0 and bring it down. 5 times, and that's it. That's even. So 0.375. Not all of these will end like that. So just like we saw before, we may have to say round to the nearest hundredth or to the nearest thousandth or whatever. Let's say I give you, let's do 9/13, and I want it to the nearest thousandth. I'm just going to write it like that because I don't feel like writing out the word thousandth. So what is it? 9 divided by 13 or 13 divided by 9? 9 divided by 13. Again, 13 doesn't go into 9, so I'm going to add my decimal point so I can add a 0. Bring my decimal point up. 6, will it go in there? Yep. 6 would be what? 78. So that's 12. Add another 0, bring it down. How about 120? 9 is 117, right? So we got 3. Add a 0, bring it down. 2 would be 26. That's 4. Are we done? We got to go one more. And the 40 would be 3 times. That'd be 39. Why do I go one more? Because to get to the nearest thousandth, I've got to know whether this stays a 2 or rounds up to a 3. The 3 here tells me it's going to stay 0.692.
Reassure that number is going to be better.
I want this one to the nearest 100,000th. I'll race you.
Yeah, you would.
That's 100,000. That'll round to 9. See if you can come up with that. Oh, like 2 of you pull out your calculators to race me. That's not even fair. I still beat you. 0.714285714 approximately on your calculators.
Did you say a 3 in that?
Well, it's 0.714285714 or 714814285. Yeah. 286 if you round it. No, the 3 was just rounding the 2 up because it was 28. Like I said, I can take that out to about 50 decimal places if you want me to. Yeah.
I trust you.
Like I told you guys before, math is about patterns. When you start to see the patterns, the calculations are easy.
What kind of pattern do you get with a 5?
Calculator only goes to 8, yeah, or 8 or 10. What's that?
How do you realize the pattern between a 5 and a 7?
Just dividing by 7s have a pattern.
7.
The 7 is a pattern. Any number divided by 7 is a pattern. For example, I'll give it to 6 decimal places. Let's go. Any number between 30 and 50. Don't give me like 35 or 42 because those are too easy.
27.
What's that, 37 or 47? 37. 37 divided by 7 is going to be 5.285,714 approximately.
Okay, so how do you get that? What's the pattern?
Because you know the pattern.
When you divide by
It's
7,
going to be 71429857114.
I could start teaching you these patterns, but it's not that I have the patterns memorized. It's
The
that
first 3
from
numbers are going to be different from I would imagine. And then
Sometimes.
714 will be after that.
sometimes. And there's the thing is, once you can divide by 7, you can divide by 14. Like 1/14th. Give me the first several digits. Divide that out.
Zero, 714.
714285714 about. Because once you start dividing it out, the pattern kicks in.
Are you the guy that goes that's on a commercial about doing math in school?
What's that?
Free fast math? You see them commercials on TV? He gets like
No, because he's learning.
ridiculous numbers and he's like, and he gets like,
There's There's a guy online. He calls himself the Math Magician or Mathemagics.
Yeah.
It's similar because he's just recognizing patterns, but he's trying to teach you the pattern, and I won't do that because then you're just memorizing patterns instead of memorizing rules. I want you to start to learn the basic rules that created all these rules that we learned, and then the patterns start to become obvious. Now, I'm not saying you're going to get there in 2 semesters. I mean, it took me years to get to where those basic rules I started to see where those basic rules fit into patterns. But hopefully we'll get you some of the basic rules so that someday some of the patterns will start to be a little bit more obvious to you at least.
I mean, just you've done it a lot. I mean,
Well, that's part of it too. Is
some of the guys I know with rifles, that you guess how much they've got to adjust by for the direction that
yeah, they can feel the wind and say, okay, I've got to adjust this much for. Yeah. Yep. Exactly. And I do have a little bit of a feel for numbers too. It's just in the big book. We're going to do some conversions here. Page 100. It's exercise 3-7. 1 through 23, the odds. So I'll give you guys the last 6 minutes here to finish up that homework from the first hour and to work on this new one. And we'll go from there.